Hey everyone, today we are doing our second to last lesson in Unit 7. So we're almost done. Today and tomorrow we're going to combine our volume and surface area problems. Um, Today we're going to look at when we would apply volume or surface area to solve a situation, to solve a problem, and when it'd be appropriate, and just kind of differentiate between the two. You can see that here in our learning goals. On the front side of your sheet, for our first activity, we have this complex figure that we're looking at. It says here's a picture of a prism. 3 students are trying to calculate the surface area of this prism. Noah says this is going to be a lot of work. We have to find the area of 14 different faces and add them up. All right. Then Elena says it's not so bad. All 12 rectangles are identical copies, so we can find the area of one of them, multiply that by 12, and then add on the area of the 2 bases. So this one says that there are 12 identical copies. Andre says, wait, I see another way. Imagine unfolding the prism into a net. We can use one large rectangle instead of 12 smaller ones. First question says, do you agree with any of them? So take a quick moment, look back at the 3 different explanations of how to solve this, and decide who you agree with. Now, hopefully, you decided that all 3 of them are correct in their reasoning. And to go back and explain that, if Noah says it's going to be a lot of work, it certainly looks like it's going to be a lot of work. We have to find the area of 14 different faces and add them up. So if you found the area of each of the surrounding rectangles, you could do that and add it up. That would give you all of these, and that's 12 different rectangles. And then we have the top and bottom, the 2 bases. So that would make 14 different shapes. But what Noah didn't realize, even though his method would be correct, is he would be finding the area of each of these rectangles, which would actually be the same area because all of them are 11 tall and 2 wide. So the length and the width of each of those rectangles would be 2 by 11 for each of these 12 surfaces. So when Elena said 12 are identical copies, she's talking about the 12 rectangles that surround the faces of the shape. Once we do 2 times 11 one time and find the area of that rectangle, then we just make it 12 times greater to represent the 12 sides. So hers would be great too. And then Andre had an interesting way of looking at it when he said that you look at the net. Remember, the net is taking a 3-dimensional shape and laying it flat. And if we were to do that, we would have one large rectangle that would be 11 in one direction, and then it would be all of these 2's combined. So it would be, let me try to explain here. It would be a rectangle that would be 11 here, and then there's going to be 12 parts because it's made up of 12 rectangles here, and it would look something like this, with each of these representing 2 inches. So that would give us 24 combined if we added up all these 2-inch sections to this one large rectangle. That is what Andre is talking about by turning this into a net. Then, of course, we'd still have to consider the bases as part of that net too. So we'd have to find the area of this base as well. All right, so all of those would work. The one big rectangle, the second question we've already answered, would be 24 by 11 to represent all 12 of those faces. And then finally, which method do you prefer? Well, that's kind of personal preference. I certainly wouldn't choose Noah's just because it's going to take a lot more calculating than is necessary. But if it was me, I probably wouldn't pick Andre either. I think I like Elena's method where she's finding the similarities. She's still calculating that area of the one rectangle and then just seeing how many other of the same rectangles there are. Okay, for the next part, it wants you to choose between volume and surface area, marking it with V or A for each of these situations. What would you have to calculate to answer the question? So the first one, how many yards of fabric are needed to sew a pillowcase? Well, a pillowcase has to go over all the surfaces of a pillow, so we would want to know the surface area of, oh, said just A. We would want to know the surface area of that pillow to create the correct size pillowcase. All right, go through the rest of these, please. Go ahead and mark them and then check back with the answer key in just a second. Okay, hopefully you remember that volume, again, is kind of the inside of a figure. So if we're talking about filling something, how much space does it have inside of it? We'd be talking about the volume, and the surface area is more of the outside of the figure, would be a good way to kind of tell the difference. So for the next one, how much cardboard to make a cereal box? We're making the outside of that box, so we need to know its surface area. The next one is talking about the amount of space inside of a rectangular hole, a rectangular foundation for a building. That's the volume. Then we have area, 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 volume, and area for the rest of those. So again, the areas are talking about the outside, how much wood is needed to build a birdhouse, or how much glass to surround a greenhouse. But then we talk about inside when we talk about filling a pool, filling it up with water. Okay, onto the back of your handout. There are a couple more situations that I would like you to find. This is again deciding between surface area and volume for these two situations. And then move on to, you know what, go ahead and do that real quick. All right, for this first one, Noah is planning to paint the birdhouse he built. He's unsure if he has enough paint. So if we're talking about painting the surfaces, every surface of that birdhouse needs to be covered. We're definitely talking about surface area. Now he's using a trapezoid base to hold modeling clay. He's unsure if the clay will all fit inside the box. So it's a box with a trapezoid base. We're talking about the volume of that box there. Next, we're going to do a little calculating here. So Andre is preparing for the school play and needs to paint a cardboard castle backdrop. It measures, and this number got messed up here, so it's 14 1/4 written over here. 14 1/4 feet by 6 feet. How much cardboard does he need to paint? Well, it doesn't tell us that it is a rectangular shape, but we are going to assume that it is. And so we would multiply the length and width of that rectangle to find that area. We would take 14 1/4 times 6 to get 85.5. And we measured that in feet, but because we're talking about area, we're talking about square feet. Now the next part says if one bottle of paint covers an area of 40 square feet, how many bottles of paint does Andre need for his backdrop? So I think this would be a great proportion problem here. So we have cans of paint and we have square footage. If one can is 40 square feet, then two cans would be 80 square feet. And looking at the square footage of that castle, we are over 80 feet. If two cans can only do 80 feet, obviously that wouldn't be enough. So really, we're only going to need part of a third can because a third can would cover a total of 120 square feet. But when it says how many bottles of paint does he need, we wouldn't want to give a partial amount here. We would want to give the whole number of bottles of paint that he would have to go buy at the store. So he's going to need 3 bottles to paint that entire backdrop. Okay, on to the final part here. Let's quickly look at this one. Each of these boxes holds 36 table tennis balls without calculating which box has the least surface area. So take a look at these 3 boxes for a moment. Make your prediction. Which one has the least surface area? Okay. Now, if we were to check, we would have to find the again, the area of each of these surfaces. We're dealing with prisms, rectangular prisms, and that means it's going to have 6 surfaces to deal with. Now we can certainly speed this up by including more surface, or by multiplying certain surfaces that are the same. So here we have 12, 12, and 16. So we're going to have, for our base, and I'm just going to consider the base the surface that this is sitting on down here. So that'd be under here. This is the base we're talking about. It's going to be 12 by 12. So we would calculate the area of that by multiplying 12 by 12. And there are 2 of those. So we want 12 by 12 by 2 to include the top surface here as well. And then, because our base is a square, all of the sides are going to have one measurement that's 12, whether it's here, here, on the left, or on the back. And it's always going to be 16 centimeters tall. So 12 times 16 would be the other measurement that I would do for these sides, these faces on the side. And then I just need to know how many there are. There are 4 that would surround it, the front and back, the left and the right. And when those all get multiplied out and then added together, what you would get is a total surface area of 1,056 square centimeters. All right. Now, I'd like you to practice with one. Go ahead and find the surface area of this next one here by calculating all 6 areas of the faces. All right, and when you did that, I hope you found that it was 1,152 square centimeters. Now, one interesting thing to note here, our 3 measurements on this shape also are consistent with the 3 measurements on this other shape. And you can see the orientation of the box is just a little bit different. This one's kind of laying down, this one's standing up. They're actually going to have the same 6 surfaces in the same area. So this one is also 1,152. And then for this last one, we're just going to jump ahead to its surface area. Now, I don't know how many of you chose this last one to have the largest surface area, but the question did ask which has the least surface area, and we'd be talking about this shape down here, which is the closest one to being a cube, to having all 3 of its dimensions the same amount. See how there's a big spread between some of the dimensions on these other figures, and that seems to create a greater surface area. All right, now jumping to the last 2, I do want you to do these on your own. You're finding, again, the surface area of these 2. These are triangular prisms. We have triangular bases and rectangular faces. So calculate the area of that base on either side, and then all the faces to find the total surface area. Check with the answer key. And again, I'll be on Zoom to help. If you have any questions, remember we are leading up to a test that will be coming right after tomorrow's lesson. Have a great day.